everyone, welcome to my channel Sai Suriyas Academy. If you are new to my channel, then hit the subscribe button and press the bell icon for more interesting videos. We had already discussed about so many types of conversions in the decimal, binary, hexa and octal. If you want, check my previous videos. It is given in the number conversion playlist. Okay, now moving on to today's topic. In today's video, we are going to discuss about octal to hexadecimal conversion and hexadecimal to octal conversion. The base idea here is we have to convert in octal to hexadecimal, we have to convert the octal into a binary. And from the binary, using the grouping method, we have to convert it into hexadecimal. And vice versa, same, the hexadecimal to octal also, the same method applied, but in the grouping method, the number of bits differs. Okay, now we can check one by one. We all knew that the octal consists of base 8 number system, which consists of digits only 0 to 7. 8 and 9 are not allowed here. Whereas in the hexadecimal, it consists of base 16. The digits from 0 to 15. And the digits from 10 to 15 is represented as alphabets A to F. And octal digit is always represented by a 3 binary digits. Whereas the hexa is represented by 4 binary digits. Here in the table, we had given the hexa numbers starting from 0 to 15. And the concerned 4-bit binary digits is given here for your reference. It can be directly substituted. These values can be directly substituted. We can see in the examples. For hexa, it is represented as 4-bit binary. When considering for octal, the same 0 to 7 digits are used, but here only 3 binary digits are implemented or used here from this table. Okay, now move on to the first example. Consider in the first example, integer number that is without any fractional part, 365 to the base of 8. Here we want to convert this 365 to the hexadecimal conversion. First, what we are going to do is, we want to substitute the concerned binary values, that is the 3-bit binary values. 3 digit, not 3-bit, 3 digit. So 3, for 3 can be taken in the table as, consider the table. Here hexa value is given and the concerned binary value is given here. For considering octal, only 3 binary digits have to be used. So, for considering 3, here it is given as 0011. We want only 3 binary digits. So, 011. Here it is represented as 011. Similarly, for 6, 110, it is substituted as 110. Similarly for 5, 101, it is represented as 101. Suppose if we can't able to remember the table hexa value, consider a small tip. Consider a number having value 15. We want to know the equivalent binary value. How it can be able to find is, divide the number by 2 continuously and note the reminders, and finally write the answer from the bottom to the top. Consider 15. 15 when divided by 2, it gives 7 as quotient and remainder as 1. Similarly, 7 when divided by 2, 2 3s are 6, remainder 1. Similarly, at the final, 3 when divided by 2, 1 into 2, 2, remainder 1. So, which gives from the bottom to top when we are writing 1, 1, 1, 1, that is the value. Similarly, for other digits, you can able to easily calculate. So, now the binary value is written as 011, 110, 101 to the base of 2. Now the binary value is found. Again we want to calculate or we want to convert it into the hexadecimal conversion. How the conversion takes place? Consider this number and we want to group the bits starting from the right to the left. Since it is an integer number, it can be done from the right to the left. So consider here we want to, since we want to convert to hexadecimal, it is grouped as 4-digit binary. So the last 4 digits 0101, it is grouped here. Again after the next 4 binary digits are 1111, which is grouped here, and at last we are left with only 1 zeros. In order to convert to hexadecimal, we have to add 3 zeros. 3 zeros can be added. That is, we are following the rule, but adding 0, since we are having 0 here, it doesn't have any value here. But according to rule, for converting to hexa, we are adding 3 zeros in the left side. Again, the values can be found for 000. The hexa value for 0, for the binary value full zeros, it is represented as 0. For 4 ones, it is represented as 15, the value, and the value 15 is represented as F. It is given here. And for 0101, the concerned hexa value is 5. So it can be written as, discarding this left hand side 0, F5 can be written, and this is the hexadecimal conversion. Now this is for the integer part. Now we have to calculate for a fractional part. How the grouping differs in the fractional part. Consider another example, 215.337. The concerned octal number have to be converted into hexadecimal. The base idea is here, by binary value substitution, 3-digit binary value, we are going to convert it into binary. So for 2152, you can refer the table directly. So I am directly telling the values, the substitution values for 2, 010, for 1, 001, for 5, 101. Similarly for 337, the values are given here, and then the values are represented. That is, after decimal point also we are doing the same substitutions, and the values can be written after the decimal point. That is, for 215, 010, 001, 101 point. For 337, 011, 011, 111, it is written. Now how the grouping differs means, this is the integer part and this is the fractional part. The same answer I had written here. So for the integer part, we have to group the bits into 4 digits starting from the right to the left. But for the fractional part, we have to group the bits starting from the left to the right. So consider, starting from right to left, the first 4 digits is 1101. Again the next one is 1000. Again we are left with a single 0. In order to convert to hexa, we are simply adding 3 zeros. And then in the after the decimal point, we are dividing starting from the left to the right. So the first 4 bits are 0110, and then again 4 ones. Again we are left with 1 0. According to the rule, we can add 3 zeros at the end. So for converting to hexadecimal, we are adding 3 zeros. 1, 3 zeros. So now this 0 represents 0, and then this 1000 represents the value 8 here, and then 1101, which represents value 30 and the concerned alphabet D. For 0110, 6. Similarly for 111, the value is 15, and the alphabet is F. For 1,000,000, we had added 3 zeros. So now the values become, for 1,000,000, the concerned hexa value is 8 here. So it is written 8. So the final value is 8D.6F8. This is the concerned hexadecimal value. Now we are going to discuss about the hexadecimal to octal conversion. That is, from the 16 base, we are going to convert it into the octal base 8 number system. The difference is in the grouping system only, but the other procedures are as it is the same. So here hexadecimal is always represented by a 4 binary digits. So for A, it is the value concerned value is 10. For the alphabet A, 10. For 10, the value is 1010. It is written here. For 2, 0010. And then for B, the concerned number is 11. And for 11, the value is 1011. For A, 10, the value is 1010. For 6, 0110. And similarly for C, the concern, for the alphabet C, the concern value is, hexa value is 12, and the value is, binary value is 1100. Again, we are going to group these bits. Now we want for octal conversion. So the number of bits has to be divided into 3 binary digits. So for the integer values, we have to start from the right to the left. The values can be divided into 3 bits. And for the, after the decimal point, the fractional value, the values can be divided as 3 bits starting from the left to the right. So by dividing 011, 101, 000 and finally 101. Similarly, when dividing from the, starting from the left to the right, we had got as 101, 001, 101 and 100. Here we have actually the correct 3 binary digits. When dividing these hexa values, we had already getting correct 3 binary digits. There is no leftover of a single digit or a double digit. So no zeros can be added or anything can be done. Directly we can substitute the octal values. So for 101, 5. For 000, 0. Similarly 1015. For 011, the value is 3. For 101, 5. For 001, 1. Similarly 1015 and 1004. The values after the decimal point can be written with the concerned decimal point followed. So the values can be written as 5053.5154. So no zeros are added here. Suppose if we are left over with a single binary digit or a double binary digit, we can add zeros here in the integer part as well as add zeros here in the fractional part. Since it is not needed, we had not added any zeros. Directly the values are grouped here and substituted, and the concerned octal value is found and it is written here. Hope you can be clear with the both type of conversions. A small recap. In octal to hexadecimal, we are converting to binary, and in the integer part, the values are grouped, have to be grouped by 4 binary digits starting from the right to the left. And the concern, for the binary values, the hexa value can be found and it is written here. A small change in the fractional values. For integer part, the values are directly represented by binary values, and for the binary values, for the integer part, it is divided, the group of bits, it can be divided into 4 binary digits starting from the right to the left. And for the fractional part, starting from the left to the right, the values can be grouped or divided, the bits can be divided. So after dividing, suppose if we are left over with a single binary digit, zeros can be added here. and for the fractional part, zeros can be added here when we are left over with a single one. And for the concerned hexa values, the binary values are given in the table. Directly we can write the answer. Suppose if we are getting 13 or 15, the concerned alphabets has to be represented. It should not be written as 13. So for 13, D is represented, for 15, F is represented. That's the conversion. Similarly for hexadecimal to octal, similarly the hexadecimal is substituted by 4 binary digits, and again using the grouping method, we are dividing the 4 binary digits into 3 binary digits and the concerned octal value is found. Now a small work for you. Convert 536.14 to the base of 8. Convert it into the hexadecimal conversion and write it in the comment section. Okay. That's all for today's video. Keep supporting Sai Suriyas Academy. Thank you. We'll meet you all in next video. Thank you.